Hello students, today in this video I am going to explain the chapter areas of parallelograms and triangles from class 9 textbook. Now before starting this chapter, let me first give you the idea about quadrilateral and its types and how to find the area of those quadrilaterals. Now what is a quadrilateral? A plane figure bounded by 4 line segments is called a quadrilateral. There is no direct formula to find the area of a quadrilateral. If we want, we can divide it into two parts by drawing a diagonal. Then we can find the area of this triangle and area of this triangle. Then if I add the area of this first triangle and area of the second triangle, then I am going to get the area of this quadrilateral. Now quadrilaterals are of two types. One is called parallelogram, where opposite sides are equal and parallel. So this is a parallelogram. These two sides are parallel. Again, these two sides are parallel. Area of the parallelogram is base into height. So this is the base and height is the perpendicular distance between the parallel sides. So this is height. So base into height will give the area of the parallelogram. Again, quadrilateral can be a trapezium where one of the opposite pairs are parallel. So here in this figure, these two sides are parallel and these two sides are not parallel. Now to find the area of a trapezium, formula is half into sum of the parallel sides into height, where height is the perpendicular distance between the parallel lines. These two are parallel lines and this is the distance between the parallel lines. Let it be h. Here we can write h. Therefore area of trapezium will be half into sum of the parallel sides into height. So area of a parallelogram is base into height, and in case of a trapezium it is half into sum of the parallel sides into height, where h is the perpendicular distance between the parallel sides. A parallelogram may be a rectangle or a rhombus. Now in case of a rectangle, opposite sides are equal and each angle is 90 degrees. So these two sides are equal, these two sides are equal, and these angles are 90 degrees. Whereas in case of a rhombus, it is also a parallelogram. Here all the sides are equal. Clear? So in case of a rectangle, opposite sides are equal and each angle is 90 degrees. Whereas in case of a rhombus, all the sides are equal. In case of a rectangle, longer one is considered as length and this one is breadth. So area of a rectangle will be length into breadth. We can write L into B. In case of a rhombus, if we want to find the area of a rhombus, we have to consider its diagonals. Suppose this diagonal is D1 and this diagonal is D2. Clear? This diagonal is D1, this diagonal is D2. Then area will be half diagonal 1 into diagonal 2. So area of a rectangle is length into breadth and area of a rhombus is half into diagonal 1 into diagonal 2. Again, combining these two, we will get another figure that is called a square. A square is a parallelogram in which all the sides are equal and each angle is of measure 90 degree, and area of a square is side square. So we can write a square, where a is the side of a square. In this chapter, we have to remember certain properties which are required while doing the sums. Suppose ABCD is a parallelogram and BD is one of its diagonal, then this diagonal will divide this parallelogram into two parts and the areas of both the parts will be same. So we can write area of triangle ABD, it will be equal to area of triangle BBC. Now property number 2 is parallelograms on the same base and between the same parallels are equal in area. Suppose AB and CF are two parallel lines and in between this I have drawn two parallelograms. One is ABCD and another is ABEF. Both the parallelograms are on the same base, that is AB, and between the parallel lines AB and EC. Then area of the first parallelogram, we can just sheet it like this, that is ABCD. We can write area of parallelogram ABCD will be equal to area of parallelogram ABEF. Why? It is because both the parallelograms, first one is ABCD, second one is ABEF. Both of them are on the same base, that is AB, and between the same parallels. So area of the first parallelogram, that is ABCD, and the area of the second parallelogram, that is ABEF, will be equal. Suppose AC is parallel to BD, and here in between these two parallel lines I have drawn two triangles. One is ACD and ACB. Both the triangles are between the same parallels and they are having the same base. Then also we can say area of triangle ACD equals to area of triangle ACB. That means triangles on the same base and between the same parallels are equal in area. Now let me start sums of exercise 9a. Here question number 1 is in the figure. Find the area of the quadrilateral ABCD. ABCD is the figure where AD is 9 cm, BC is 8 cm, CD is 17 cm, and we have to find the area of this figure. In this sum we have to find the area of this quadrilateral. This quadrilateral is divided into two parts. This is one triangle, this is another triangle. Here this angle is 90 degree, so this is base, this is height. So area of this triangle can be calculated by using the formula half into base into height. And area of this triangle can be calculated by using the same formula half into base into height. But here this base is not known. So first of all, by using Pythagoras theorem, we have to find the length of BD. So from this triangle, this part and these parts are known, so I can calculate BD by using Pythagoras theorem. Once I know BD, then again by using Pythagoras theorem, AB can be calculated. In right triangle DBC, here this is 90 degrees, so this is the hypotenuse. So we have to start from hypotenuse in Pythagoras theorem. So we can write DC square equals to DB square plus BC square. The bracket you should write Pythagoras theorem. It is better to write in full. So DC square is DB square plus BC square. Since this is 90 degree, so this opposite side is the hypotenuse, and in case of Pythagoras theorem we have to start from hypotenuse. So I have written DC square is DB square plus BC square. Now DC is given in the question 17, it will be 17 square. DB is not known, so let it be DB square plus BC is 8. Now 17 square is 289 equals to DB square plus 64. So 289 minus 64 will give DB square. So DB square will be 225. So DB will be root over 225, which will give 15, because 15 square is 225, so it will be 15 centimeters. So in this triangle, by using Pythagoras theorem, we got DB as 15 centimeter. Here we can write 15 centimeter. Since these two sides are known, now this AB can be calculated again by using Pythagoras theorem. So we can write in right triangle DAB. Here this is 90, so this is the hypotenuse. So we can write DB square equals to AD square plus AB square by using Pythagoras theorem. Now DB, already we have calculated, it is 15 square equals to AD is 9, so it will be 9 square plus AB square. 15 square is 225 equals to 9 square is 81 plus AB square. So 225 minus 81 equals to AB square. That means 144. 225 minus 81 is 144 equals to AB square. So AB equals to root over 144, which will give 12 centimeters. So this part is 12 centimeters. Now we have to find the area of this figure. For this triangle I will use half into base into height. For this triangle also half into base into height. And then by adding the areas we can find the area of the quadrilateral. Area of ABCD, it will be area of triangle ABD plus area of triangle DBC. Now we know area of triangle is half into base into height. So we can write half into AB into AD plus, in case of DBC, it is half into DB into BC. Now half, AB is 12 centimeter, AD is 9 centimeter plus half, DB is 15 centimeter and BC is 8 centimeter. This 2 and 12 can be cancelled, we'll get 6. 2 and 8 can be cancelled, it will be 4. 6 9 is 54 plus 4 15 is 60. 60 plus 54, it will give 114. So 114 centimeter square is the area of the required quadrilateral. Question number 2. In the figure, show that ABCD is a parallelogram and calculate the area of this figure. Now, here we can write angle ABD equals to angle BDC, both equals to 90 degree. We can write each 90 degree. First of all, we have to show that this is a parallelogram. Here we can say this is 90 degree, this is 90 degree. Since these two angles, which are alternate interior angles, these two angles are equal, that means AB is parallel to CD. Therefore, AB parallel to CD as alternate interior angles are equal. Since these two alternate interior angles are equal, so this line and this line are parallel. Again, it is given that both of them are 5 centimeter. Again, it is given AB equals to CD. So one of the opposite pairs are equal as well as parallel. Therefore, ABCD is a parallelogram. So we can write therefore ABCD is a parallelogram. Why? Because one pair of opposite sides, that is AB and CD of quadrilateral ABCD are equal and parallel. So first of all, we found that these two angles are equal. Therefore, AB is parallel to CD. Again, AB equal to CD. Since one pair of opposite sides are equal and parallel, so ABCD is a parallelogram. Now, we have to find the area of this figure. And we know area of a parallelogram is base into height. Here base is 5, height is 7. So, area will be 5 into 7. Therefore, area of parallelogram ABCD, it will be base into height. Here base is AB and height is DB. AB is given in the question 5 centimeter and DB is 7 centimeter. So it will be centimeter square. 5 7 is 35 centimeter square. Therefore, area of the given figure is 35 centimeter square. In question number 3, it is given, find the area of a rhombus, the length of whose diagonals are 16 centimeter and 24 centimeter. We can consider let diagonal 1 be 16 centimeter and diagonal 2 be 24 centimeter, and we are to find the area of the rhombus. Now we know area of a rhombus is half into diagonal 1 into diagonal 2. So we can write area of rhombus equals to half into diagonal 1 into diagonal 2. So half into diagonal 1 is 16 centimeter, diagonal 2 is 24 centimeter. So here you have to write centimeter square. 2, I can cancel 8. So 8 2 is 16 and 8 into 24, it will give 192 centimeter square. Therefore, area of the rhombus is 192 centimeter square, and that's the answer. In question number 4, it is given, calculate the area of the trapezium PQRS as given in the figure. Here it is given this part is 8 centimeter, this is 8 centimeter, this is 17 centimeter, and this is 8 centimeter. We know the area of a trapezium is half sum of the parallel sides, because these two are parallel sides. So sum of the parallel sides into height. But here height is not known. So first of all, by using Pythagoras theorem, we have to calculate this height. So in this triangle, if I apply Pythagoras theorem, then RT can be calculated. And if I know this height, Then by using the formula half into sum of the parallel sides into height, we can calculate the area of the trapezium. As in this figure, we have to first find RT, which is the perpendicular distance between the parallel sides. So in triangle RTQ, we can apply Pythagoras theorem. So we can write in right triangle RTQ, RQ square equals to RT square plus TQ square by using Pythagoras theorem. Now RQ, it is given 17. So 17 square equals to RT square plus 8 square. 17 square is 289 equals to RT square plus 64. So we can write RT square equals to 289 minus 64. 289 minus 64. So RT square will be 225. So RT equals to root over 225, which will give 15, because 15 square is 225. We can write it is 15 centimeters. So we got perpendicular distance between the parallel sides is 15 centimeter. Here you can write 15 centimeter. Since we know the perpendicular distance, now we can apply the formula half into sum of the parallel sides into height. In trapezium PQRS, here PQ is 8 plus 8, that will give 16 centimeter, because this part is 8, this part is 8, 8 plus 8 16. RS, which is another parallel side, it is also 8 centimeter, and the perpendicular distance RT is given as 15 centimeter. Now area of trapezium PQRS, it will be half into sum of the parallel sides. Sum of the parallel sides means PQ plus RS into perpendicular distance, that is RT. So it will be half PQ into RS. So it will be 16 plus 8. 16 plus 8 into 15. So half 16 plus 8, it will give you 24 into 15, 212 ja, and 12 into 15 is 180, so it will be 180 centimeter square. Therefore area of the trapezium is 180 centimeter square. In question number 5, it is given in the figure ABCD is a trapezium in which AB parallel to DC, AB equals to 7 centimeter, AD equals to BC equals to 5 centimeter, and the distance between AB and DC is 4 centimeter. Find the length of DC and hence find the area of trapezium ABCD. So in this figure, this is 5 centimeter, this is 4 centimeter, this is 7 centimeter, this is also 5 centimeter, and it is given these two lines are parallel, and this one must be the perpendicular because it is the distance between two lines, and always we consider perpendicular line segment as the distance between parallel lines. Now since it is a trapezium, so area of the trapezium is half into sum of the parallel sides into height. Since this side is not known, we have to calculate CD first. In this triangle, this is 5, this is 4. So by using Pythagoras theorem, we can calculate DL. Similarly, we can calculate CM also. And in this part, which is a rectangle, since this is 7, this also will be 7 because opposite sides of a rectangle are equal. So once we know the side CD, then we can calculate the area of the trapezium. Let me show how to do this sum. Using Pythagoras theorem, we can calculate DL. So we can write in right triangle DLA, DA square equals to DL square plus LA square. In this triangle, this is 90 degrees, so this will be the hypotenuse. So it will be DA square equal to DL square plus LA square. You can write here by using Pythagoras theorem. Now DA square is 5 square equals to DL square plus LA square. LA square is 4 square. 5 square is 25 equals to DL square plus 4 square is 16. So 25 minus 16 equals to DL square. So 9 equals to DL square. So DL equals to root over 9, and root over 9 will be 3. So 3 centimeter is the length of DL. Similarly, CM also will be equal to 3 centimeter. So here DL is 3 centimeter, CM also 3 centimeter. AB ML is a rectangle. Since AB is 7, ML also will be 7. We can write ML equals to AB equals to 7 centimeter. Therefore CD equals to CM plus ML plus DL. CM is 3 centimeter, ML equal to 7 centimeter, DL is also 3 centimeter. So 7 plus 3 10 plus 3 13. So it will be 13 centimeter. So this side is 7 centimeter, this side is 13 centimeter, and the perpendicular distance is 4. Therefore area of the trapezium ABCD, area of trapezium ABCD, we know area of the trapezium formula is half into sum of the parallel sides, that is AB plus CD, into perpendicular distance, that is AL. Now half into AB is 7 plus CD is 13 into AL is 4. So it will be half into 7 plus 13, it is 20, into 4, 2 10 ja 20. So 4 10 ja 40 centimeter squared. Therefore, required area of the trapezium is 40 centimeter square and the length of CD is 13 centimeter. So these two are the required answers. Question number 6. In the figure, ABCD is a trapezium in which AB is parallel to CD. We have to prove that area of AOD equals to area of triangle BOC. In this sum, we have to show that area of triangle AOD and area of triangle BOC, areas of these two triangles are equal. We know triangles on the same base and between the same parallels have equal area. Therefore, area of triangle ADC equals to area of triangle BDC. Both are on the same base, both are on the same base CD, and between the parallels AB and CD. Clear? ADC and BDC, both the triangles are on the same base, that is CD, and between the parallels CD and AB. Therefore area of triangle ADC must be equal to area of triangle BDC. Now from these two triangles, if I subtract the common area, that is DOC, then I am going to get area of triangle ADC minus area of triangle DOC equal to area of triangle BDC minus area of triangle DOC. So from both the triangles we are subtracting the common area, that is DOC. Now ADC minus DOC, we are left with AOD. Similarly BDC minus DOC, then I am left with BOC. Clear? From the triangle ADC, if I subtract this common area, this is the common part. If this part is subtracted, then we are left with AOD. Again, from the triangle BDC, if we subtract the common area, that is DOC, then we are left with BOC. So we can write, therefore, area of triangle AOD equals to area of triangle BOC, and this is what we have to prove. In question number 7, it is given that in this quadrilateral, AL is perpendicular to BD and CM is perpendicular to BD, and we have to show area of this quadrilateral is half into BD into AL into CM. Now in this sum we have to consider the area of the triangle, that is half into base into height. Now if we consider the triangle ABD, then this will be the base and this will be the height. So we can write area of triangle ABD, it is equals to half into BD into AL. Let it be equation number 1. Again, area of triangle BDC, here BD is the base, CM is the height, so we can write half into BD into CM. Let it be equation number 2. Here we have applied the formula. Area of the triangle is half into base into height. Now area, we can write now area of quadrilateral ABCD, it can be written as area of triangle ABD plus area of triangle BDC. So area of the whole quadrilateral will be area of triangle ABD plus area of triangle BDC. Now area of ABD, it is half into BD into AL plus area of BDC, it is half into BD into CM. From this I can take half BD common. So if I take half into BD common, then we are left with AL plus CM. And this is what we have to prove, that area of the quadrilateral is half into BD into AL plus CM. So this is the required answer. So here you can write proved. I hope this sum is clear, and this is the last sum from this exercise and even from this chapter. So that's all for today. In the next video I'm going to start chapter 13 from class 9 textbook. Till then, bye bye, take care and wait for the next part.